Okay. So yesterday, up to your exist operators we discussed in the last session. Okay, now right. And now next one. Okay. In the latest one, we have here one more we called as here scalar sub query. Exciting. Scalar sub query. Okay. Okay. Now I say okay. Kunch. Okay. So now next one, scalar subquery. And these subqueries, especially why we called as it is a scalar subquery and how this subqueries can be used. Okay. For example, here every column is called as a scalar. Scalar is nothing but a single column or a single value. Okay. So generally, when we want to write your select query, so we can write like select a star from, and we are passing what now? Table name. So this is a select a statement we all of you know. And here in place of that means whatever we are using star. Okay, what is the mean by star? All columns. So that means in place of star, can I give it my column name? Yes or no? Yes. Like you can pass number of columns. Okay, column 1, column 2, column 3. Like I can pass it here. And now this is also called as what now? Select query only. But in place of star, I'm using my required column names. So scalar means what I said, column. Every column is called as one scalar. Okay. And now in the position of your column name, I need to prepare here what is now subquery. Subquery 1, comma, next. In the position of column name, I'm going to writing here subquery number 2. Subquery 2. Okay, comma, and so on. So in place of column names, when we provide a subquery statement, then the type of queries are called as a scalar subqueries we called. The type of subqueries are called as what? Scalar subqueries we call. Okay, na? Right on below. Providing a subquery, in place of column or column name in select statement is called as a scalar subquery. Okay, is called as a scalar subquery. Or else another definition is what now? Providing a subquery under select statement is called as under select statement is called as scalar subquery. Okay, and now this is your syntax of scalar subquery. How to? Okay, right. And this is what, and now suppose if I want to take a small example on this, okay, let me come out and see. Okay, so these are actually my tables, EMP and DEPT. Okay, these are some tables now. So the two tables, department and EMP table. Okay. Now what I want to do, I'm going to writing a small query under by using of scalar subquery like select count of star from EMP table. So this is one scalar subquery we called. And the second one we called as what now? Select count of star from what now? DEPT. It's a one more subquery we are using. And from here, which table means by default table is what now? Dual. So once I executed now, you can see, so what it was happen, every scalar subquery result, that means the result of a scalar subquery, how it was showing the result of every scalar subquery means it will be showing like a column. It was showing like a column value. So it was showing like a column. Got it my point now? So now, so the result of every scalar subquery or the result of every scalar subquery will show or will act as an column. Okay, that the values will be showing as a columns wise. Okay, that's why the scalar subqueries are where you want to use it. Means that whenever you need to convert the row information as a column, if you want to convert rows into columns wise, if you want to show it, there we can use a scalar subqueries. Understand na? So whenever you need to convert your rows as a column. Okay, for example, this is one example. First write down here. Now, here observe. Scalar subqueries are basically we are using to conversion of your rows into columns wise. For example, EMP table you can see guys. In this EMP table, EMP number, name, job, MGR, hire date, salary, commission, department number. These are called as what now? Columns. And can you see your 20s and 30s and 10s? These are all are called as what now? Rows. These are all are rows. Now what I want to do, the row information, the 10th rows, 20th rows and 30th rows. These are raw data. Now I need to show as a column and convert as a column. In that cases, the scalar subqueries will be using like this now. Now you can see select offer, select sum of salary from EMP where department number is equals to 10. Understand now? So this is one subquery. This subquery result I will show as a 10. I'm showing as a 10 and a 10 is your header. So 10 is your header. That header I will compulsory to keep in your double quotes now. So now one thing. And the second one is called as select sum of salary, okay, from EMP where DEPT number is equals to 20. That I'm showing as an header of 20. Next, of select sum of salary from EMP where DEPT number is equals to 30. And this is, I will show, okay, where DEPT number is equals to 30. Then I will show as a 30 is header for me, okay, from the dual table. Now we can see, okay, actually the 10, 20 and 30s, these are not a columns, these are actually rows. And this row information about 10, about 20, about 30. So this row information about 10, 20, 30, now I'm showing as your columns wise. Okay, na? So in that cases, scalar will be useful. Otherwise, don't use. Other than this, there is no other use of a scalar. Okay, right on below. Okay, right. So these are your subqueries in our SQL. Okay, now, and the next type is right down below, indexes. Okay, right. And the indexes, okay, so this mechanism when it was required, and the main concept and main purpose of indexes are what? Okay, and how these indexes in real time the people are using. Okay, so basically, guys, here your database indexes, okay, it was working same as your book index. So can you remember book index page? Yes or no? What is the advantage of index page in textbook? Is there any advantage we have? Yes. What is advantage? So if I want to pick a particular topic, then the topic I can pick with the help of what now? Index. Because in index page, what it was happen? It was having some page number. So in index page, suppose your textbook is having suppose 500 page numbers are there. So out of 500 page numbers, suppose in your Oracle textbook, there are 500 page numbers. But just imagine your publisher is not given any index page in the textbook. And the customer is purchased that book. But he didn't observe index page. Okay. And he left out, okay, from his shop. Okay. And later he was trying to open the book and he checked it out. The customer checked it out. There is no index page. If there is a no index page in the textbook, the problem is what now? If any one topic, if I want to retrieve from the textbook, okay, then what we want to do, each and every page number we need to search. Is that correct? So each and every page number we need to search. It means that it's a time consumer. Yes. For example, there are two cases are there. One is the best case and worst case. Suppose in the best case, your required topic, okay, out of 500 page numbers, for example, your required topic is having in the page number 1 only. Your required topic is having under page number 1. So that means my required topic is available under or at a page number 1. So in that case, what it was happen, I have time saving because when I open, my topic is find it. So this is what we call the best case. So when it was the best case, I don't have any problem. So I can pick my required topic immediately. Okay. But worst case is what now? Our required topic is having in a last page. Okay, suppose our required topic is having at a last page. Then what we want to do? Your entire book you need to search. Yes or no? Your entire book you need to search. So entire book means how many page numbers? 500 page numbers we need to search. Is it time consuming now? Yes. So that is what without index, okay, the problem. That's why you can see almost every textbook or every book you can see my first page is called as what now? Index page. So that advantage of index page is what now? Suppose if I need a particular topic, joins. Joins is located in which page number as a user, I don't know. So then what we want to do first, I have to go, okay, where? Index page. First, I need to check this Oracle textbook is having index page or not. If it is there, then what is my first priority? I want to go index page only. So I'm going to index page and my required topic join. The joins is located page number 45. Okay. If I know the page number 45, then can I go to directly jump now? Yes or no? Are you directly going to 45 page number and we are taking our required topic? Otherwise, are you searching again 1, 2, 3, 4, 5, 6? Are you searching again? No, because my required topic is which location? 45th location. So where is my topic is there in the which page number my topic was located? If I know that information, then why should I want to search again page number 1, page number 2, page number 3? Is it necessary to search? No need. So directly we jump to 45. Again, I close my book. Suppose I wanted one more topic, stored procedures. So stored procedures also where it is in my textbook, I don't know. Again, what should be follow? Again, index page. Again, I'm going to index page and searching in index page. My stored procedure concept is located in which page number? Suppose the page number is given 350th page number. So what do you want to do? Are you directly jump to 350 or else are you searching from 1, 2, 3, 4, 5, 6? Directly jump. So that means what you understand, index pages advantage is what now? Fastly or quickly we can retrieve our required topic. Yes or no? So your searching time will be reduced. So it reduces searching time. Okay, na? So it reduces searching time. And fastly we can take our required topic. That your page, your topic, sorry, your textbook is having how many number of pages, I don't mind. But if you have 1,000 pages or 5,000 pages or 10,000 pages, I don't mind. But when we have what now? Index page. Okay, na? So with the help of index page, out of any number of pages, okay, based on the index page information, I can directly jump to that page number and pick my required topic from there. Okay, na? So how we can say, okay, how we can say to fastly or quickly accessing of our required topic from a textbook by using of a book index page, same to same in database also. Okay, na? In database also, just imagine here, okay, how many employees details we have here? 14 employees. Out of 14 employees, a specific employee data if I want to retrieve now. A specific employee data if I want to retrieve now. So suppose I wanted the employee whose employee number 7788. Then what we want to do? How are you writing your query? Select star from EMP where EMP number is equals to 7788. This is what we are writing. But whenever we are sending this request to my database server, first as per the request, your database server will go to your table. So on which column conditional basis are you retrieving the data? EMP number column values basis. So then your server will go to EMP number column and checking on this column, is there any index object is created by programmer or not? First it will be checked. If it is created index object, then index object technique will be followed. Okay. If it is not created index object on this column, then what it was happen here, it will be searching each and every row in a table. So each and every row in a table until unless your request will be satisfied. So now how many rows it will be searching total? 14 rows. That's called as a top to bottom. So just imagine, for example, your table is having a 1 lakh rows and you want it out of 1 lakh rows. Which row you want it? 7788 row. So that means a 7788 row data retrieval purpose. Your Oracle server is going to be table and searching how many rows? 1 lakh rows are searching. So it is a time consumer now? Yes. So to overcome this problem, the people was introduced what now? Index. Okay. And index, how it was working, simple, you are understanding what now? It's a similar to book index page. How are you using book index page for fast and quickly taking off your required topic? Same as database indexes also we are using to retrieving our required row from your table fastly or quickly. Okay, now this is the main cause of what now? index, right down below. Index. It is a database object which is used to retrieve the required row or rows from a table fastly. By using indexes, we can reduce the searching time and improve the performance of a database. Okay, now all databases are supporting the following two types of searching mechanisms. Okay, first one we called as here table scan mechanism, and second one is called as what now? Index scan mechanism. So almost every database is supported two types of scanning mechanisms or searching mechanisms. One is a table scan and one we called as a index scan. Okay, now in this, what is a table scan and what is index scan? Observe carefully. So table scan is nothing but, guys, here. This scan is called as, it is a default scanning mechanism. It is a default scan mechanism here. Scan of a database. In this scan, Oracle server is scanning the entire table for the required data, purpose. Okay, now, so in the scan, Oracle server is scanning the entire table for the required data purpose. Okay, so how it is, sir? Let me come out and see. Suppose, are you sending one request to your database server? Select a star from where salary is equals to 3,000. Suppose I'm going to sending like this. And what I'm saying here, whenever you want to send this request to my Oracle server will go to your database table. It will go to your database table. So whatever the table you have in the database, so that table, okay, it will be going faster. And now what it will do, so which column wise are you retrieving your data? On that column, okay, The user is created any index facility is applied or not, checking first of all. Suppose on that particular column, if there is a no index is created by programmer, if there is no index object is created by programmer, then Oracle server by default, which scan is performed? Table scan. Which scan is performed? Table scan. And the table scan, whatever I said here, now you can come out and see. Suppose this is your table. Okay, select a star from EMP. This is my table. Now I'm going to retrieve some data where salary is equals to 3000. Then what it will do now, as per this condition, first checking on the salary column, index object is there or not there. So if it is not there, then this conditional value is comparing with each and every value of your table. Okay, so how it was comparing now, you can see salary is equals to 3000. 3000 is equals to 800. Condition true or false? False. Next, 1600 is equals to 3000. False. Next, 1250. False. Next, 29. False. Next, 1250. False. Next, 2450. False. Next, 2450. False. Next, 3000. True? Yes. Then this record will be picked from your table. But after picking your data, it's not like that your searching will be stopped. Okay, now? So many people, what they expected, sir, my required data was found now. So then my Oracle will stop my searching. Yes or no? So some people are thinking like that. But remember, will never stop. Suppose your Oracle will be stopped here itself, then tell me how many rows I can pick now? Up to here only searching, and I point out here and I just pick out and I stop it there itself. That means how many rows will come? Only one row will come. But can you remember one more employee salary is also 3000 now? That actually how many people have 3000? 2. But if I stop here itself, so how many rows can I get? 1. So that means your output is right or wrong? Wrong. That's why you are okay after found your required data, but still your searching will never stop. It will be again continue. Next continue. 5000 is equals to 3000. False. 1500 is equals to 3000. False. 1100 is equals to 3000. False. 950 is equals to 3000. False. Next, 3000 is equals to 3000. True. Again, this is also pick. Okay, this row also I'm going to pick now. Okay, now I'm going to pick now. So that means here, how many rows I'm going to pick here? 2 rows. Then after again, last one. So 1300 is equals to 3000. False. So that means table scan is nothing but what now? From your top to bottom, each and every row is going to be search. Understand? Na? So even though, for example, your required row is there at first level only. Okay, na? For example, but still here it will be getting, but remaining rows also searching. Okay, that means your required value is having in the first row, na, middle of the row, na, last row, na, it's none of the matter. If your required value is there in the first case, okay, but still it was searching entire table. Your required value was there in the middle of the table, even though searching entire table. If your required row is having bottom of the table, even though it was searching entire table. So here the matter is what now? Your value, where it was located in first position, middle of the position, last position, it's none of the matter. But it should be searching your entire table. That's why it is called as what now? Table scanning. In the name only there. What is that? Table scan. That means entire table will be scanned. Is it clear now? So that means here, total how many rows you are comparing here? 14 rows. And each row, Okay, suppose each row purpose, it will take 1 second of time by your Oracle server. Then this output to producing purpose, how much time it will be spent here? 14 seconds of time was spent it. So that means within 14 seconds, your output was released by your Oracle. Okay, so or else this output releasing purpose, Oracle server was taken how many seconds? 14 seconds. If you have a 1 lakh row, then how many seconds? 1 lakh seconds. This is called a time consume process. Understand now? Right down below. Below write down. In this table scan, Oracle server is searching complete table. That means how many rows here? 14 rows for the above required data. Okay now? Right. So the Oracle server searching complete table. That means 14 rows for the above required data. Understand now? So for example, each row is equals to so for example, a row is equals to, if it will take 1 second of time, then total how many seconds here? 14 seconds. Okay. Oracle for just a idea purpose. For example, one row is equals to 1 second, then 14 seconds it will take time. Now you can see. Now I can go for index scan. So now the second mechanism is called a index scan. Now index scan is also I'm going to apply. Okay now? So now this method I'm going to apply. Already table scan method we applied here. It was taking already 14 seconds time. But the second one is what now? Index scan. This mechanism also I'm going to implement for the same data retrieval purpose. And let me check. It will take 14 seconds, more than 14 seconds it will take, or less than 14 seconds it will take. So that a time comparison we want to do. Suppose after index scan also, it will be taking more than 14 seconds, then which will be priorable? Table scan is priorable. Okay. Suppose your index scan will take less than 14 seconds to get the same data, then which will be priorable? Index scan. So now I have to check which scan is or which scan will take less time to get a salary is equals to 3,000. Okay, now, but in this index scan, what it was happen, before you need to perform this index scan, first user has to create a index objects. Okay, now, so and these index objects are creating on particular columns in your table. Understand or not? Particular columns. And on which column are you created index object? That column is called as a indexed key column, and based on that indexed key column only data will be searched. That means index scan technique will not search entire the table. It was searching only based on indexed key column wise only search, but it doesn't go entire table. Okay now, so this is one advantage of what now index. Okay, right on. So when we create an index object on a particular column or columns in a table, those column or columns are called as indexed key column, and based on an indexed key column only, our Oracle server is searching for required data. Okay, right. But here some types of indexes we have here. Okay, so how many types of indexes we observe? Below write down types of indexes. There are two types, guys, here. First one we called as here B tree index or indexes. Second one we called as here bitmap index. So B tree and bitmap indexes, these are the two types of indexes we can create in our Oracle tables. Okay, now, so come to B tree indexes first we will discuss, then after we will go for bitmap. So B tree indexes, again, it was classified into some types, guys, here. Okay, now in this first one we called as here simple index. Okay, second one we called as here composite index. Third one we called as here unique index. And the next one we called as here functional based index. Okay, so B tree indexes again classified into four types: simple, composite, unique, functional based index. Okay, let me see one by one. I will explain to you. First one takes siding simple index. So when we called as indexes are called as simple index means when we create or when we created an index object based on a single column is called as a simple index. Is called as what now? Simple index. So that means whenever the programmer is created index object on how many columns? In one column in a table, then we called a simple. What is the syntax to create your index object? Means that create index and I have to give index name on table name of pass your column name. Okay, now? Now you can see. Now I will go for this, how to create your observe. But before I'm creating index, okay, on my previously which column I used here, salary column. First, I want to check whether on this column any indexes are there or not there. I want to check first of all. How I want to check my indexes are there or not there on the table means there is a one data dictionary we have. The data dictionary is called as user underscore ind underscore columns. So this is one of the data dictionary. Can you remember the data dictionaries? I explained that. In constants, I didn't explain. Okay. So now data dictionary, I will explain. This is what now? It's one of the predefined table. So in this predefined table, your all indexes related informations will be saved. Okay, now? So all your indexes information will be saved. And this is one of the system defined table. This is one of the system defined table. It's not user defined. When you install your Oracle software, along with software, some predefined tables also we will be get. Okay, now can you find out in the early classes when you write your system login to system, we are writing select a star from tab. There are so many tables are coming to you. In those tables, one of the table is what now? User underscore ind underscore columns. So these are all are we called as a system defined or predefined table. So this is not user creations. So like this, there are so many tables are there. Like you have observed, there are thousands about tables are we are fetched out when you're writing select a star from tab. So like in that one of the table user underscore ind underscore columns. So in this table, these are called as a columns. Can you see? This is a table. And the desk keyword I'm using for what purpose? Whenever you want to see the structure of table purpose. So when I'm using desk user underscore ind underscore columns, can you see this is called a complete structure? It same look like table structure now? Yes. In this, these are called as a column names. These are called as a column names. And every column you can see data type is also there. Varchar 2, varchar 2, varchar 2, number, varchar 2, number. So these are data types of each and every column. And by default, all columns are accepting nulls. Okay. So this is what your table structure. In this table structure, there are three columns. Carefully observe. What is this? Index name, table name, column name. So these three are important for me. So now I'm going to writing now. Select what I want to show, column name, comma, index name. The columns I'm calling now. From these two columns I'm calling from which table? User underscore ind underscore columns. Okay. Where I want to see which table indexes I want to see, EMP table. So you're careful observe. Index name, table name, column name. These are called a columns. Columns of which table? User underscore ind underscore columns table. It's one of the predefined. So in this table, your column name along with index name will be showing. And now you can go to execute now. So present on my EMP table, is there any column is having indexer? No. So that means there is no indexes are available here. So now what I want to do, now I'm creating a index. What is index syntax? Create index I1 on EMP of which column I'm creating? Salary. Because previous my table scan I'm performing on which column? Salary column. So how many seconds time? 14 seconds. Now after index creation, how many seconds? Observe. So now here salary, I'm creating index. After created index, let you call the same thing, the data dictionary or predefined table. Now see on your column name, what is the column name? Salary. What is your index name? I1. So index is created. Yes. After created, then you can call your request. What is the request? Where salary is equals to 3000. So now this request I'm sending to my Oracle before index creation or after index creation? After index creation. Then what it was happening here? As per this request will go to Oracle server. Server will go to your which table? EMP table. In EMP table, which column is checking? Salary column. On salary column, you have an indexer? Yes. Then which scan is performed? Index scan is performed. Previously, table scan because index is not created. So now index scan will be performing. So based on this index scan technique, now your data will be retrieval. That how it is, I will tell you. So finally, it was getting your same result, but internal execution process, I will explain right down below. So now create your write this and below take a note point. What is the note point here? To view column name along with index name of a particular table, then we follow the following syntax. Follow the following syntax is, what is our syntax here? Select column underscore name, comma, index underscore name from user underscore ind underscore columns, where table underscore name is equals to, here you need to pass your table name. So what is my table name here? EMP. And here one thing should be remember guys, here EMP table or table name must be in capital. Here compulsory capital name only use. Don't use small names. So take comment here. Table name should be in a capital. ఆన్లైన్ ఇంటికి వెళ్ళిపో ఇంట్లో తీసుకుంటా చెప్పు ఆన్లైన్ చెప్తున్నాను సార్ అని చెప్పి ఎక్కడ మళ్ళీ నాకు అక్కడ ఎక్కడ ఎందుకు అనుకుని అక్కడికి వెళ్ళిపోతున్నాను చెప్తాను నేను ఓకే. So table name should be in a capital. It must be capital. Either your table name in small case character or uppercase character, none of the matter. It should be in a capitals only. Okay. Now after that, you will be get your index here. So this is the information about your index. Okay. This is also right down below. Okay, right. So after index is created, okay, I1 on your table name of some particular column. Okay, then what it was happen, you can see internal process we should know it here. So how after created indexes, okay, how your B tree structure will be preparing by Oracle. Okay, so for example, if a book was the publisher is there, publishers publishing books. Yes or no? Okay. Suppose one publisher, he was going to be preparing a book. Who will create an index page? Customer or publisher? Publisher. So publisher, he was going to be preparing index page, and that index page he was going to be attaching to your textbook. Then after he will be selling. Yes or no? Is sold out or not? So after that index page, that means who was prepared by index pages by publishers. So those index page books, who will purchase? Customers. That means index page is preparing by publisher, using by customers. Concept understand now? Same as here also. Once I created my index object, on which column I created? Salary column. Whenever user is created an object to the salary column, then what internally Oracle server will do? What internally Oracle server will do means, which column I created? Salary column. Then this column only, not other columns, only this indexed column. This indexed column data, whatever it was there here, this data in which format here it is? This is which format? Tabular format. This is which format? Table format. So this table format of a column data converting into which format? B tree format. Tree. Tree means root after parents, parents after child. Yes or no? So that means this column data, now it was converting into binary tree. Can you remember in your B.Tech or M.Tech, you have a binary searching? Yes or no? Now your data will be like it will be convert your data not into your tabular format. It was arranging your data in which format? Binary tree format. Okay, so that means your data is not in tabular. Your tabular column data after index creation, the data convert and arranging into which format? B tree structure format. B tree structure format. And this format, who was preparing internally? Oracle. When it was prepared Oracle, when user is created, index. Okay, na? So this tree structure, it will be prepared. Preparing and arranging your data in tree structure format. Then after, based on this tree structure, your required data where it was there in the table, that will be found and sending that value to client. Okay, na? But how this tree structure will be formed? How my salary column values will arranging into tree structure format. Okay, na? That explanation I will give tomorrow. Okay, na? So tomorrow, internal explanation I will give to you. Okay, and based on that, you will get some idea how the B tree structures will be forming. Then after, how the data searching. Okay, na? So that I will go for tomorrow class. Okay, right. So I was uploaded. Once check it out. Okay, na? Right, guys. Thank you. Thank you so much.